Welcome back to episode 36 of our programming series. Today we're going to talk about how our programs are actually laid out and formatted in the main memory once they're ready to run. So let's do a quick recap. Before we can actually run our program, we have to take the file that we wrote, compile it, and then assemble it into an object file. And then we take those object files, however many there are, and link them together into an executable. Then we save that executable onto our secondary memory, whether it be a hard disk drive or solid state drive, whatever. And then at any point, we can go ahead and grab that executable, push it onto the main memory, and run it on the CPU here. So we have to actually take it from the secondary memory and put it onto the main memory so that it can execute. And we do that with the use of a loader. So a loader is part of your operating system, and we'll talk about operating systems later. But just know a loader takes the actual executable from the secondary memory and pushes it onto the main memory. So let's just say this executable that we have in our secondary memory only takes up this amount of space in our main memory, so it doesn't take up the full amount of main memory. And this is why you can actually run multiple applications, multiple programs on your computer. This is why you can have 5 Chrome tabs open, why you can have the File Explorer open, why you can run a video in the background. It's because our RAM is big enough to support multiple programs. In most cases, our main memory is going to be split up into 8-bit chunks. So every byte, we're going to have an address. So these 8 bits are going to have the address 1, these 8 bits are going to have the address 2, and so on and so forth. In modern systems, we see most main memory anywhere from 4 gigabytes to 32 gigabytes. So there's going to be a lot of addresses. Anyways, once our program is loaded onto our main memory, we're going to have to split it up in a way that is logical so we can actually use our instructions and store data. So this is what's known as the application memory layout. So in the application memory layout, this is for each program that's in our RAM here. Every program has the same layout. We're going to have 4 sections. We have the text section, the global section, heap section, and stack section. So the text section is where we're going to store all of our executable instructions. So let's say in our executable that we loaded onto main memory, somewhere in here, there's an instruction that says, okay, add 1 plus 2. We're going to take that instruction and push it into this text section of memory. And then we have a global section of memory. And this is just where we store our global variables. So let's say in a program we use a global variable called pi, and we set it to 3.14. Obviously, pi is always going to be equal to 3.14, so it's not going to change. It's going to stay the same value throughout the program. So that's going to be part of our global section of memory. Now we have what are known as the stack section and the heap section of memory, and these are the 2 most important ones. The stack section of memory is where we're going to store our statically allocated variables and objects, and then our heap section is where we're going to store our dynamically created objects and variables. And you might not know what I mean by statically created and dynamically created. We're going to do a video on that in the near future. So all you need to know at this point is that when a program is loaded onto main memory, it's separated into 4 different sections: the text section, global section, heap section, and stack section.